In this tutorial, we're kind of going to go over Ladybug and how we can use that to analyze surfaces in our models pretty quickly in Rhino. So the first thing you're going to need to do is download Ladybug, and I think a lot have already done that for tech, but if you haven't, it's important that you download that from Food for Rhino. But when you install it, there's a few ways to check that it worked correctly, but I'm going to go over this one in this tutorial. So the first one is when you place an object down, any of the Ladybug ones, this ribbon up here is going to show all the add-ons to Grasshopper. So within Grasshopper, there's one called Ladybug or LB, and these are all the commands within Ladybug. And if you place one down, and I and a lot of others had this problem, but this button or any of the buttons you put down would always be red, and you wouldn't be able to use those buttons at all, and Ladybug wouldn't really work. And we figured out to solve that issue, you actually have to go into the actual Python script, but it's pretty easy. So if you click on the Rhino window and go to Edit Python Script here, and then you go to Tools, Options. Right here, the issue normally is this one, the Ladybug Tools Python lib site packages. And it's normally just linked incorrectly. So to change that, you click this button, Add to Search Path, and you follow exactly where in the directory this is. So you'd go down and you'd find the folder, the subfolder, and get all the way down until site packages. And then once you link it and reload Rhino, Ladybug should work again. But in this tutorial, I'm also going to go over some initial ways that we can use Ladybug to graph surfaces with climate analysis. And I'll just start teaching how to import EPW files, which you may have done with Climate Consultant already, and how we can use that data a little more. So first off, I'm just going to create sort of a surface with like a box in it, just so that we can see how shadows and casting shadows would work. But I'm just going to set up a box. I'll make it shaded. I'll put a surface beneath it, just so the shadows have something to reflect on. And it doesn't really matter the size at the moment. But for now, that's just going to be our base model. And now we can go into the actual Grasshopper script. So the first thing I like to do is just set up a script that I can basically use whenever I need to. And the first thing is to get that EPW file. So I actually like to create a button that brings you directly to the EPW website. And that would be EPW map. And when you put a Boolean toggle, this basically just creates a button to turn it to true or false. When you plug that in and click true, it opens up a window and it directly brings you to that website. So now you can just type in the location that you want. We'll pick Los Angeles for now. Just pick whichever spot. We'll go down here somewhere. And you're going to copy that link to your clipboard. Perfect. Now we go back to our file. Now we're going to actually put in what's going to read that. So now you need to use the command download EPW. And it's going to be this one. So now you need to plug in that URL you just copied. And to do that, you just put in a panel, double click in the panel, and then paste that URL. And you're going to plug that weather URL in. And you see it turned green, or it turned gray. It got rid of that yellow notification. That means that it successfully read that URL. And now for it to actually read that information, you need to use the command import EPW. That's going to be this one, Ladybug import EPW. You're going to plug that EPW file in. You can see that yellow notification went away. And now it has all this information just from that URL. It has the location, the bulb temperature, all of these things. And now you can do a lot of stuff with this information. So what we do with it now has a lot of ramifications. So I'm just going to group this for now. We're going to group it. And all of this is just the setup. So we'll just title that so when I come back and use this file later, I know what I need to plug in and what I need to change. Now the first thing we're going to do is do sun path hours. Sun path. So this is just going to be Ladybug sun path right here. So this is going to basically do the sun path for this given location, and using that sun path, I'm going to track where on the surface would actually receive sunlight versus where it would receive shadows. And the first step to do that is I need to bring the location information in first off. And I also need to bring in the HOYS, which is the hours of the year. And a lot of this other stuff would make your information, whatever you output, more exact, but just for it to work, you just need those two. So I'm going to set up the HOY over here actually, which is the hours of the year. And you have two options. You can either do a specific date and time, or you can do a like an analysis period. So it would be like the entire year or a certain 6 months. So I'm going to set up both of those so when I come back later, I can just choose. The first one, HOY. This one's going to be hour of the year. And here you could plug in a specific month. It starts 1 through 12, a specific day, 1 through 31, specific hour, but that one's 0 through 23. As you can see, I hover over it, tells you, and a specific minute. This is very, very specific. So if you pick a very specific time that you want to analyze your building, that's perfect, but most of the time you just do like a year or 6 months or something. And that one you're going to use analysis period. Ladybug analysis period. And here you're going to pick the start month, 1 through 12. So I'm going to put 1 for January. End month, I'm going to put as 12, December. Start day is 1 through 31, so I'm going to do 1. End day, I'm going to do 31. And then start hour, 0 through 23. So I'm going to start with 0, 23. And that's perfect. So now we can use that HOI. We plug it into this HOI. You can see it draws that sun path for it. And now that it's doing this, you can tell that it's working, obviously, because it was able to map this based on your location, based on the time of the year, which was the entire year. So that's perfect. Now we're going to make it so it's reactive with these objects. And we're going to use the command direct sun hours. And this is going to measure exactly how much of each portion of this surface receives sun and how many hours. So we're going to plug in the vectors from the sun path into the vectors here. And then we're going to need geometry and then the context. So in this case, I'm going to make the geometry this surface, and we're actually going to need to make a couple brevs for this. So I'm going to say this surface is the geometry that I want to see how much sun hours it gets. So I'm going to set 1 brev. Perfect. Geometry. And then I'm going to do another brep for the context. And I want this to be the context in this scenario so I can see the shadows that it casts. Set 1 brep. Here we go. Context. We also need to tell it what grid size to use. So like that's going to be how big the squares are that it's going to map. So it's going to basically make a bunch of little squares. And it's going to map each one of those with how many sun hours it's going to get. So the smaller grid size you use, the more exact it's going to get. I'm just going to do 1 for now, and that should be enough. And then I need to do another toggle, another Boolean toggle, in order to tell it to run or not. So I'm going to turn it here, and I'm going to say set it to true. Double click. It might take a second. And then I'm going to pause the video and then I'll come back when it loads. It just finished. It only probably took a couple minutes, but I realized that I made the grid size actually pretty small. And I think that's likely because my units are, let's see, oh, they're in feet. Okay, I guess I made this grid really big then, but you can see it's pretty exact. It can go a lot faster if you just make the number like 10 and the grid size a lot bigger. But you can start to see that it like tells you how many hours it's going to receive, and it really makes sense because if the sun path was coming from the south side like you were saying, that yeah, these spots would receive less light because they'd be casted in a shadow, and these blue spots would actually receive no light. So it's really useful if you have more complex things like context and you're building facades and stuff like that, because you could map this on the floors inside your building. You can map it on the glass on the exterior of the building just for context purposes, and you can do a lot more stuff like that. And I actually have an example of it over here. I used just like an older building. I just wanted to map it on the surfaces of the glazing. So go back to here. We click here. You can see it maps like where the overhangs would cover and like how strong this light would be. So we see that these windows over here receive a lot of strong light. So I really should figure out a way to make this a little less harsh, especially since it's that west light. And it could be really useful for iteration phases and for informing your next design. So you can see how useful this is. I'm going to group these. I'm just going to name this just HOY. I'll group these and say sun hours. And these groupings aren't necessary. It's just nice when you make this file and then you save it and then you can come back and use it over and over again. You can also do it for radiation if you'd like. This is sky matrix. I don't really use this one that much because sun hours seems to be more useful, but you do almost the same stuff. You need location. You need direct radiation, though. This comes directly from the EPW file. So you need radiation, and then you need you also need the HOY, and then you need another radiation. There, and now it should work. And now you use the command incident radiation. You plug in the sky matrix, and then you basically would plug in the exact same stuff, and you'd get the exact same output nearly, just measured differently. So this would be geometry, this would be context. I'm going to turn on the Boolean toggle to true. I'm going to turn that one off, but I'm going to make the grid size a little bigger this time so it goes faster. Set that to true, and you can see it does almost the same thing, but now it's measured in kilowatt hours per meter squared rather than just hours, which is a little easier to understand. But this one's fun too to use, and you can group it and do the same thing. And you can use either of these for later, and there's other ones that Ladybug can do too, like wind.